Hey guys, this is OC coming at you with another guide notes section. I wanted to take a look at metric system and dimensional analysis because it's probably been a while, or maybe you've never even done it. And so I think a little review and look at what these have to offer and what the purpose of this crap is important to do because understanding the basics of all our measurements is the fundamental idea of why we do anything, and how I can base my empirical values off of some defined kind of thing. So let's take a look at that today, and we're going to run through the basic idea of the SI system and metric system and look at the conversions that we can do between the different systems. Well, the first reason is, why do we need a set system? I mean, you probably have seen something like this in the book that has like this list of quantities and all this good stuff, and it's like, oh, look at all this. But you're like, why? Like, why can't we do like, the good old American system, the imperial system? Why don't we say 12 inches, equals 1 foot? Like, I know that makes sense to me. But then you have to ask yourself, well, why does that make sense? No, why? 12 inches in a foot. 12. Who picked 12? Why 12? Is there something about 12 that we love? I don't know. It just seems like 12 seems to be a good number. I don't know. Well, does that mean, does it make it easy for someone who's not familiar with the system to say, well, that means 12 feet equals the next larger unit, maybe 1 yard? Is this true? Heck no, that's straight up dumb. You know that's not right. You know they're only 3 feet. 3 feet is 1 yard. But wait. Whoa, wait a second. 12 equals 1 to convert from inches to foot. So here we decide to use 3. 12, 3. Did someone hit their head before they come up with this crap? I don't know. And then you think, well, how many yards are in a mile? Off the top of my head, I don't remember. I know there's like 5,000 some feet, but I know it ain't 3 yards in 1 mile. That just ain't right either. So again, like, who came up with these dumb systems? They don't seem to make any sense. All right. So the idea here is why do I have these things if none of these things seem to make any sense? Okay, so the basic idea was, let's first set quantities. All right, and these are our SI, the Système International. These are like the international standard units for base measurements. So any and all measurements you ever make are based off of either these direct measurements or a combination, aka derived values of these. Like derived values like square areas, volumes, things like that. A joule energy is a derived unit. These are all base units. Okay, so length is a base unit. Okay, it's a one-dimension unit. The quantity symbol's an L. It's a meter, and we got an M. What is a meter? Back in the old days, we used to have this one little thing, and I shouldn't say little, it's a meter long. And you might say, well, how did I know that this, platinum rhodium iridium rod was 1 meter? Well, some guy sat there one day and said, behold, and I have said this is the meter. And that was a meter, because somebody said this is a meter. You might say, well, if you don't know history, what an inch is has changed over time. Why? Because it gets defined off of dumb things like king's thumb lengths, and feet is the distance from here to here, and that's something that changes from all the time. So we said, listen, let's just say this bar right here is a meter. Okay, and boy, they go to the extreme with these things. These things are stored usually in temperature controlled systems, and aren't removed very often. But nowadays, a lot of these things have been changed to observable phenomena, like the length value is actually defined off the path of the length that the path of light travels in a certain time frame, very short time frame. Time is again off of some oscillations. They're all basically nowadays off some observable thing that is non-changing. The only thing that really hasn't changed yet is mass. There is a kilogram, be wary that the standard unit for a mass is a kilogram. I know those of you who already had some experience with metric are like, kilo is a prefix. Yeah, well, I didn't say these were the base units of the metric system. These are essentially the SI. These are the base units that we base all other units in the world off of. So the problem was a gram is a pretty small thing. If you think of gram as 1/1000th of a kilogram, holy crap, that's a really small thing. So the kilogram was something much easier to make a value off of. So we use the kilogram for it. The kilogram actually still is a physical standard stored in the world. It is a physical standard. If you ever want to find something interesting, the kilogram has been shown to lose a very tiny bit of mass right now, and we're still trying to see what we can do to maybe fix that problem. There are some ideas on the horizon to get it based off some observable phenomena, because we can't have a kilogram change because every other kilogram in the world is based off that kilogram. You change that kilogram, every other kilogram is in flux then. Okay, so we can't have that. All right. And here's some all the basic unit abbreviations, that we see for a lot of these things. Again, why abbreviations? Because rule number 2, chemists are lazy. Rule number 1, chemists are always right. Rule number 2, we're lazy. And since we're lazy, a meter can be an M, a kilogram is a kg, a second is an S, Kelvin's a capital K. The reason we don't use lowercase k is because lowercase k is used generically for a generic constant value. Look, we get so lazy. We abbreviate mole. We take off the E. That's how lazy we are. Okay. Electrical current, so that's the amount of electrons essentially passing through a certain amount of area in a time frame. Sorry, length in a time frame. And amperage and candela measures luminous intensity. How much light is being produced, sort of a thing. Okay, so those are our base systems. Okay, and these are our base units. Right, but again, you might say, how does that solve, this problem? Okay, well, here's the cool thing. With any base system or derived system, by the way, some examples of derived, like I said, meter cubed is a derived unit. Milliliter is a derived. You might say, isn't that a volume? But, if you look up here, do you see volume? No. Well, because, meter cubed is volume. Milliliter is volume. So essentially, a milliliter is what we call a cubic centimeter, or a cm cubed. Okay. In fact, it's a really cool relationship you should definitely know, is that 1 milliliter is 1 cc of acting stat. You see that in a lot of fun ER shows and stuff like that. 1 cc or 1 cm. These are all the same thing. They're all equivalent to each other. Kind of cool. The joule is a kilogram meter squared per second squared. Really freaky unit. Really cool. But you can see kilogram. Really cool measurements are in there. Kilogram, meter, second. So it's comprised of 3 different base units. Okay, so those are derived. Okay, here is where it gets freaking sweet. I'm telling you, this is what makes the metric system awesome. All right, makes it so cool. All right, so here's what we're gonna do. We have set. There have been set prefixes, and these are just a sample of some of them. There are bigger than these, and there are smaller than these. Okay, but I'm just doing the ones that are interesting or common. Okay, all right. So what we say is, there's our base measurement. Like, let's take a meter, okay? If I have a meter, 1 m for a meter, okay? What if I want to express something big? Like, that's the purpose of the mile. Like, you don't measure the distance from here to DC in inches, because that's just straight up dumb. Like, that'd be a lot of inches, okay? So why would you ever do that? Well, same thing in meter. What if the meter just ain't gonna cut it? What if it's a bad measuring unit because you're dealing with such a large one? Or what if you do a little bitty tiny one, like for like a diameter of a cell? Okay, what do you want? You said all I have is a meter. Well, that sucks. In American, we got multiple things. You got them here in metric too. The cool thing about metric is, back here where you had all these weird numbers, and then let's say we wanted to go from like ounces to pounds. How many ounces are in 1 lb? Okay, well, that's 16. Holy crap, another number that doesn't coincide with any other number. Americans. Okay, I'm an American too, by the way. But anyway, that's just dumb. So what we said is, no matter what system you're in, these prefixes govern the size of your measurement. All of them. I don't care. It could be a derived unit. It could be the joule. It could be liters, meter cubes, anything. Candela, mole, second. I don't care. You can put these prefixes and it makes the unit bigger or it makes it a little bit smaller. All right, which is nice. So if you want to measure the distance from here to DC, which I'm in Hagerstown, Maryland, then meter is just a horribly bad unit for us. So we might want to use something like a kilometer or a kilometer, okay? You should actually hear my little rant about why kilometer is such a bad thing. And you can see up here it says kilo is 1,000 factors of the base unit. So that means 1 kilometer is 1,000 meters. There you go. Well, wait a sec. What if it was 1 kilogram? See, right there. You don't call it a kilogram, do you? I didn't think so. See, kilometer, kilogram. Yeah, you don't say kilogram. Kilogram. What's a 1 kilogram? Oh, geez. I don't know. What is it? Wait. Kilo. Kilo's always 1,000. Yes. Yes. So 1 kilogram is 1,000 grams. Every time. A kilo anything is 1,000 of that measuring. Even if it's a derived. Let's say I had 1 kilo candela. A kilo candela equals, I don't know what a candela is. Oh, but wait, it's a kilo. So it's 1,000 candelas. It is freaking sweet, man. I'm telling you. Oh, yeah. Metric system, prefixes, awesome. Awesome. Okay? And they work for even smallers, too. What if I had 1 micro candela? Well, that's this really small decimal. I hope you don't mind. I'm going to use scientific notation. That's 1 times 10 to the negative 6th candela. Bam! In your face. Because that's what a micro is. A micro is always that. A micrometer is 1 times 10 to the negative 6 meters. That'd be good for this diameter of a cell or something like that. Because it fits it. I can scale up and down a unit just by using a prefix. Sweet! That is boss. Okay? No longer do you have to remember 12 and 16 and 3, 5,180. Dude, that stuff, that's old and busted. This is the new hotness. Metric system, new hotness. Okay? So that's why we use it. That is what makes it so sweet. Okay? How do you convert, though? Because it makes sense to us to convert American units a lot because we're used to it. Okay? So you're like thinking, oh, I'm going from bigger to smaller. I divide by 12. Oh, I'm going bigger here. I'm going small. I'm going to multiply by 16. How in the heck did you ever know how to do that? Okay? Listen, we did that a long time ago. If you're using this for review, this is going to be cake time. If this is brand new to you, this is going to be the most amazing thing you've ever seen in your life. So let's talk about this term dimensional analysis. Okay? Back in math class, a lot of times we only care about the numbers. In science, back in the last lesson, we care about units as well. Okay? We even care about significant figures. Okay? In this little dimensional analysis, we're going to take a look at units because units are just as important in a measurement as the number. Remember, we never write down a number like 32. 32 what? That's like saying you went to the mall and your friend, Billy's like, Billy's like, hey, OC, yo man, what'd you get at the mall? Oh, I got 5. 5? 5 what? Okay, measurements have not only a quantity, but a measured value. So like a millimole. Okay? All right? So that, it has both. And in dimensional analysis, I care about both. I'm going to do stuff to this number, and I'm going to do stuff to this unit. All right? The goal will be is to cancel out the unit. Make the unit go bye-bye, and introduce a brand new unit, something I want. So, how do I do that? Okay? Well, first off, you see all these units I wrote up here? I can write these as conversion factors. What that means is I can write them like 1 kilogram is 1,000 grams, okay? Using that like as a divide sign. But I could also reverse this. Cool thing about conversion units, they're all equal to 1 because they don't really change what you're doing. Remember, if you think about, oh, I have $0.32. I could also say you have 32 cents. It's the same thing because it's equal to 1. It's all the same stuff. So in this case, 1 kilogram over 1,000 grams is equal to 1,000 grams over 1 kilogram. Okay? So any of these things I can write, any of them, and even this one, can be written either way. You're like, well, how do, which way do I write? I don't know. Do I multiply by 1,000 or divide by 1,000? Oh, right there. Stop thinking about whether you're going to multiply or divide. We don't care. Dimensional analysis is going to sing us a song and make it so nice and make us feel so warm and comfy. And it's going to be cake time. And we like cake time because I like eating cake. We all like eating cake. So how do I use this? Here's the basic idea. You're going to take your given. Usually your given's over 1. If you're an AP or you're doing a little more advanced, you may have this over some other unit like velocities and things like that, or conversion of densities. But again, that's cake time. Don't worry about it. We'll get there, okay? You take your given, put it over 1. You then multiply by a conversion factor. You then may multiply by another conversion factor. You then might do a third one until you have the unit of what you want. Okay? That is what you want to do here. All right? So, underneath this example here, let me show you what I'm talking about, and then I'll do this example. Okay? So, let's take this 32 millimoles and say I want to convert to moles. Okay? Oh, milli, I don't know what a millimole is. I don't even know what a mole is. I'm in AP, I know what a mole is. But I'm in honors, I don't know what a mole is. Who cares? It doesn't matter. A milli anything. So, 1 millimole is equal to, a millimole is 0.001 moles, okay? Now, if you deal with me a lot of times, I tend to not deal with decimals, so if you did 1,000 millimoles is a mole, that's fine too. Don't worry about that. I'll just stick to one way in this demonstration, though. So that's 1,000th of a mole. Why? Because a milli anything. A milli donkey is 1,000th of a donkey. A milli gigantor is 1,000th of a gigantor. A deci Dora the Explorer is 1/10 of a Dora. And we could do with 1/10 of a Dora. But anyway, doesn't kill a Quatlu is going to be 1,000 Quatlus. Okay? That doesn't matter. Okay? All right. So here's a conversion factor. Okay? I want to go from millimole to mole. This conversion has both in it. Sweet! So let's take our given and put it over 1. Millimole, this is what we were given, put it over 1. All right, score. Now, let's do a conversion factor. You're like, oh, but I see, remember? I don't know, do I write it this way or that way? I don't, okay, all right. Here's where you're going to love dimensional analysis. It's going to get you through so many problems just because you think through this. I don't care about the number. Did he just say he doesn't care about the number? I don't care about the number right now. The number doesn't mean a lot of anything. Let's get the labels to go bye-bye and work out. Okay? Because let's remember one thing from math class. If I had 2 over 2, what's that equal? 1. What about 3 over 3? 1. Yes. Score. What if I had x over x? Oh, I think I would carry the 1! So it doesn't matter. Essentially what happens is when you put something over itself, it cancels itself out to 1. It goes away. It cancels itself out. Well, you want the unit of a mole. We do not want the millimole anymore. We don't want you, millimole. We don't like you. So we want to get the millimole so that it cancels out. Well, how do we get it to cancel out? Well, if there's 1 on top, there's got to be 1 on bottom. Conversely, you could say if there's already one on the bottom, you want one on top. Okay, but so that means on this conversion factor, I want millimole down here. Why? Because now it's on the bottom of that millimole. And when they divide, they will cancel themselves out. Yes! Touchdown! Bam! And then if this is a conversion factor we're going to use, if I use millimole on one side, then the other side's got to have moles, so moles got to go on top. Millimole's got to go on the bottom to cancel. You got to think about what you want to cancel. Once you figure that out, oh, it's so easy. Okay? So let's do that. Let's just put the millimole and mole there. And the number, so here's where the number comes. It just sticks with the label, man. So what stick with the millimole? 1 was with the millimole, so we put a 1 here. What was with the mole? 0.001. Because it went with the mole. And do I have what I want? Heck yeah, I do. I got mole. Alright? So now I got 0.032 moles. Take it to the bank. Booyah! Kick time! How do I know how to do that? I just followed the math. The math says do 32 times that divided by 1. By the way, you could divide by 1s here. Not going to do anything. Okay? Don't worry. They're not going to hurt anything. So some people always put them in your calculator. Some people don't. Do whatever you like. Okay? All right? Does that make sense to you? Are you feeling that like a little bit better there? Because I hope so. Okay? All right. So, next thing. Goodbye. I might have to keep that millimole part there because I went and did some other stuff. All right. So now, let's get rid of this. Let's forget about this. Let's do this problem here. Okay? Convert 45.5 kilograms to grams. All right? So 45.5 kilograms. That's what I'm given. So it goes over 0, 5, 6, 1. Right, 1. Always put it over 1. Okay. And now I need to do a conversion factor. I don't even know what a gram is. Oh, right, that's that SI. That's mass. Right. Gram's not SI unit. Kilogram is. But again, kilo means, is going to mean 1,000. I look up here, a kilo anything is 1,000 of that base unit. So I know that for 1 kilogram, that's 1,000 grams. All right, so there's a conversion factor. So I want to get from kilograms to grams. Oh, do I multiply by 1,000 or divide? I don't know. You don't have to memorize that. Why? Why memorize it? Just look at your units. Kilograms on top here. You do not want kilograms. You just want grams. So we want kilogram to go bye-bye. See ya. So again, we want kilogram to be over top of the kilogram. Well, that means on this conversion factor, kilograms got to be on the bottom. And since I'm using this conversion factor, gram goes on top. And where do the numbers go? They just stick with their labels. 1 went with the kilogram. 1,000 went with the gram. Bam. Call it a day. Touchdown. Super sweet, man. Look at that. Now it's just math time. Plug and chug, choo-choo train. Choo-choo. Kilogram cancels out. Gram is the only unit left in the problem. Because kilogram went bye-bye, canceled out. Grams left. Okay? So we have 45,500 there. All right? That's dimensional analysis. It doesn't get much harder. If you can always think to yourself, I just need to get the units to cancel out, everything's fine. All right? If you haven't noticed a lot of times, you want to pretty much put whatever unit's here down here because you want it to go away. All right? All right. What if I want to do one that goes from one prefixed unit to another prefixed unit? Is there a table for that? Oh, no. This table right here gets me from any prefix to the base. So this thing allows me to go from any prefix between the base unit. All right? So this doesn't go from prefix to prefix. Now, some of you smart people, you probably can figure out how to go from one prefix to another. If you can do that, more power to you, man. I'm not going to do that because I don't want to confuse anybody. But that's right, you can do it that way. I'm not going to do it that way. So essentially, if I want to go to another prefix, I can go from one prefix to a base, and then go from a base to another prefix. Okay? All right? Because I can link any prefix to the base, and the base links to every other prefix. So I know how to, we can get from a nanometer, again, I could care less if it's a nanoquatlu, because a nano is 1/1000th, okay? I know I can get from 1 nanometer to a meter, and then, okay, so that's from one prefix to another. So now I want to go from the base unit to another prefix, so I can go from centimeters to meters. Okay. Again, 1 nanometer, I'm going to use scientific notation. If you want to use that full big number up there, go for it. Okay. So this is 1 times 10 to the negative 9th. That's a billionth. Okay. 1 centimeter is 0.01 meters. Okay. All right. So I have my two conversion factors. And now I'm ready to rock, man. Because with these two conversion factors, I'm ready to go. FYI, you might be worried about sig figs here. Remember, if you stay within one measuring system, these are defined. Someone sat there and said, I dub nano 1/1000th of whatever you're talking about. So it's definitely that. That is 100% the conversion. Okay? Pretty much the only time you have to worry about sig figs and conversion is you convert from American to metric. Okay, that's the only time. That's the only time you have to really worry about it. One notable exception to that idea is there is exactly 2.54 centimeters is exactly 1 inch. You don't want to look up the inch and figure out what this inch thing is, man. Inch is crazy. The history of an inch, amazing. Fun times, man. Go look it up. Anyway, so here's what I'm going to do. Same process. Put my given over 1. 385 nanometers, little bitty, little small, a nano. This is like wavelength of light small, okay? Bluish kind of range, all right? So remember, our idea here a while ago was I can go from one prefix to the base, and from that base back to another prefix. So let's keep that in mind. I want to go to the base. Well, I can get to the base. I have two conversions that get me to the base. Well, which one do I want? I want to get the centimeter. So you're thinking, well, I like that one. Boy, that says cm in it. But if I use that, I never get rid of the nm. Oh, remember, dimensional analysis. Get rid of old units. So I want to get rid of this nm because I don't see nm in this one here. I don't see it. I don't. So let's get rid of nm first. So my first conversion factor should be the one that has nm in it. Where do I want nm to go? Well, let's see. Right there it is. It's nm. Oh, hey, look, I'm starting with nm's. Okay, OC said something. I always want these to cancel out. So, where's it got to be? Top or bottom? Think about that for 30 seconds. Maybe 10. Where do you want that nm to be? Top or bottom? I know you're thinking. Let's hope you're thinking on the bottom. Nanometer. Because it will cancel out when we divide. Remember, something over the same thing is going to cancel out. 5 over 5 is 1. X over x1. A quatlu over a quatlu is 1. It cancels out. Okay? And that means that the meter goes on top because I said I'm using this conversion. Okay? Don't mishmash conversions. Okay? Yes, some of you pro people, cool. Not pro, don't worry about that, okay? So where does the number go, though? I don't know where the number goes. Remember, it just follows the units. So 1 was with the nanometer, 1. 1 times 10 to the negative 9th was with the meter. It's easy as that. Okay. All right, and I'll cross this conversion off. I'm finished using that because I don't want to use it again. All right. Now, am I where I want yet? Is that what I want? Meter? No, silly OC. We want centimeters. So I got to convert again. You might say, why don't you hit equals here? Dude, when you hit equals in a calculator, you know, you round a little bit because you know what you'll do? You'll write down a number and then go do something else, and you only write down like 3 decimal places. Well, whenever you round, you tend to, you know, mess up the number some. Don't do that. Just keep going, man. The calculator can handle 15 multiplications in a row or more. Who cares? Let it do it. All right? So now, okay, I don't want meter in my answer. I want centimeter. So if meter's up on top, where do I want it in this conversion? Because I don't want meter anymore. On the bottom. Bam! Cake time. And since I'm using this conversion to get the centimeter, meter to centimeter. Where do the numbers go? Pfft, just look. One's with the cm. 0.01 is with rm. And now it's plug and chug. Choo-choo. Choo-choo. Time. I'll do 385. You can divide by 1 in your calculator. Ain't going to do anything. I multiply by this top number, then divide by 1. Ain't going to do anything. Multiply by 1. Ain't going to do anything. Divide by that. So when I type it in, I'm literally going to type in 385 times 1 times 10 to the negative 9th divided by that. Okay? Because I'm multiplying by 1, dividing by 1 ain't going to do anything. But if it makes you feel better, do it. Okay? Because it doesn't hurt. All right? Okay. How do I do something that has cubes? Oh, crap. Man. And let's get some variation here. Let's go to joules. These are joules now. Wee joules. So you can see it don't matter what our unit is. Let's work on something you're not used to. Okay. Centijoule cubed. I don't even know what a centijoule cubed is. We don't care. Okay. So here's the thing. I want to convert 42.2 cubic centijoules. Doesn't really make a lot of sense. Should have probably stick with meter. Whatever. Okay? Over 1. And you want to go to a millijoule cubed. Well, you're thinking, well, okay, hey, listen, I remember that. I can see the similarities from the last problem. This is a 2 prefix problem. So from the last problem, we know 1 centijoule, centimeter, doesn't matter, is equal to 0.01 centijoule, joules. Sorry, my writing sucks. Okay? All right? And we also know that 1 millijoule is equal to 0.001 joules. But wait, these are cubes. These aren't cubes. Remember, those were, oh crap, those were base conversions. But what happens if there are cubes and squares? It's real easy. You just, if you have a cube or a square or a 4th, 5th, 20th power, take this conversion and cube it. Take this conversion and cube it. And everything else is the same. So essentially here I had 0.01. Now I'm going to have 0.01 cubed. Okay? 0.01 cubed. That's going to be, well, that's 10 to the negative second, so it's going to be 10 to the negative 6, I'm pretty sure here. So 0.01 cubed. Ha! I am right. All right? So this is going to turn into 1 centijoule cubed, because I cubed the whole thing, is equal to, look, when I cubed that, I cubed the labels. Hey, the labels are important. And this becomes 1 times 10 to the negative 6 joule cubes. And then 1 millijoule cube, because I'm going to cube it too, is equal to 1 times 10 to the negative 9th joule cubes. Again, I just took this, put it in the calculator, and hit the cube. Okay? So I could actually get it out. Other than that now, it's back to the last problem, folks. You just want your labels to cancel out. Centijoule cubes here, so I gotta have centijoule cube here. Okay? And that means we're going to use the first conversion that goes to a joule cube. And then I want to get rid of my joule cube because I don't want joule cubed here. I want millijoule cubed. So millijoule cube cube. And now I just put the numbers in with what they match with. So 1 times 10 to the 6th, negative 6th. And then 1 times 10 to the negative 9th. And this is going to be 1. And you plug and chug. Choo-choo! So that's going to be, what, 42,200 millijoule cubes. Okay. I'm going to do a YouTube video on why that cube works out the way it is, and I'm going to show you a little demo about that. So look in the comment section, and I'll show you why that is the way it is, and I'll use the meter example so you get a little more visual understanding about why we would cube the conversion because we're dealing with cubes, and why 1,000 centimeters, 100 centimeters is not exactly a meter. In the cube world. It is in 1 dimension, not in 3 dimensions, or even in 2 or 4 or 8, okay? So look in the comment section. I'll have that link up there shortly, okay? All right. If you're not doing anything advanced, you're pretty much done. If you want to see how to do a problem that starts off with something on the bottom of the given, let me show you how to do it. APers is going to be kind of important to you, okay? So here's a problem where I'm given like a velocity. Well, actually, it isn't a velocity. It's a fluid speed. Okay, milliliters per second, liters per hour. Maybe you got a hot water tank that's leaking like that, and you want to see, well, is this thing like, do I need to worry about this? Well, 56 milliliters per second, you better be worrying about it. You probably got a flood in your basement. But anyway, let's take a look. Okay, so this time we usually put our given over 1, because we'd say 56 milliliters. Okay. Now remember, by the way, when I write this, everybody sometimes gets a little confused. That's how you write this. You write a unit like that if you want to keep one line when you're typing. But realize in dimensional analysis, this looks like this: 56 milliliters over 1 second. Okay. That's just to save space. All right. So don't be afraid to change that over. Don't write per second over 1. That's going to confuse the heck out of you. Okay. So usually we put this over 1, and it still technically is, but it's per 1 second now. Okay. Now, I want to get to liters per hour. So I want to end up with the units of a L over an hour. All right. Oh my God, I got to do 2 conversions. It's easy. All you do, it's like doing 2 of the conversions at one time. Just pick one of the units, convert it. Then start doing the other one. All in the same problem. And it's cake time, man. Just don't stop because you got it. So let's just do one. In fact, let's go ahead and convert milliliters because that seems comfortable. Okay? So I want to go to liters. All right? Well, we know that there are, for every milliliter, ooh, that's an ugly M, milliliter, okay, we can convert to liters. And we know that there's 0.001 liters is 1 milliliter. Again, in class, and probably from now on in here, I'll probably say 1,000 because I hate using decimals in these. Okay? And so that's 1 milliliter. That cancels out our milliliter. Bam! So we already got the L part of this. You might say time to hit equals. No, not time to hit equals because you're not finished. We haven't gotten our bottom unit yet. Let's just keep converting. You're like, well, how do I convert a second though because it's on the bottom? Remember, why does anything cancel out? Why does 5... how do I cancel 5 out? I put it over top of itself. This one's just on the bottom already. So we need to put one on the top. So let's put it on the top. So if seconds is on the bottom already, I want to do seconds up there. I want to go to hours. Okay? Some of you might know how many seconds are in an hour. Kudos. It's 3,600. But I'm going to do the ones because I'm a simpleton. I like knowing just kind of simple things. So I can go seconds to minutes. Minutes, and then I can go from minutes to hours. Okay. In fact, by doing this, you'll see the conversion. So there's 60 seconds in 1 minute, and there's 60 minutes in 1 hour. There's the 3,600. All right. Minutes go bye-bye. Seconds go bye-bye. And if you look, the only thing we haven't canceled out are liters and hours. They're oriented just like they are here. Bada bing, bada boom, crank time. Plug and chug. Choo-choo! It's cake time, guys. Okay? Dimensional analysis. Without you, where would we ever be? All right. I love dimensional analysis. I love the metric system. It makes so much sense. All right. And why does it make sense? Why is the metric system so good? First off, we have the set quantities. We have these 7 base units that make up everything else. We actually have standards for them. Okay. It's not like off of, it's not based off the president's nose length, because that's dumb, because we get new presidents all the time. That'd be straight up dumb. We have actual set values now. All right. And we have set conversion quantity sizes. We don't have to remember, oh, this is fluid ounces instead of like weight ounces. And this isn't feet, though it's not 3 or 12 or 16 or 144. In the metric system, man, everything's a factor of 10. It is awesome. Factors of 10 are amazing. All right. And it doesn't matter what you apply these to. We could even do mega inches and micro inches if you wanted to. It would mean the same thing. Micro inch would be a millionth of an inch. All right. And dimensional analysis. Oh, where have you been all my life? If I treat the labels and the units that are part of the measurement as part of the thing I'm converting, the unit tells me where things go. This unit can actually help me put the conversion factor in perfectly, so I don't have to sit there and say, oh, do I multiply or divide? Once the unit's in there, man, it's cake time. Cake time. Don't forget that if you're going from one prefix to another, take a pit stop in the base unit. Go from one base unit to the next, go from one prefix to the base, then go to the other prefix. If you're pro time, maybe you do that one step, but that's okay. Not for us right now. Remember, if you have squares or cubes, you still use the same conversion factors, just square or cube them, and then use it just the same way. And if you're pro time, no big deal. Your givens just might not look, natural, because they're not going to look so normal off the top of your head. We get to heat, man, and we start dealing with that joule, kilogram meter squared per second squared. We can cancel stuff out of that. Just treat it as one big conversion. It's just a little puzzle to get your labels at the beginning to match the labels at your end. Okay? So, guys, you can do this. This is awesome. All right, this is awesome sauce. So this is for you. I hope this works out for you. Again, if you want more on that information about the cubes and square stuff, look for the YouTube video. I'll do an actual film demonstration of why the heck it is the way it is that we cube those conversions like we do or square them. All right, guys. I'll see you next time. Have a good one. Later.